This is the homework help video for Unit 4 homework number 1. I'll start with number 2 here. Identify and define the 3 different types of chemical bonds. The first type of chemical bond is an ionic bond. And the big deal here is no sharing of electrons. No sharing of electrons. And it's the result of large differences in electronegativity. The second type of bond is a covalent bond. And here we have a small difference in electronegativity and electrons are shared. That's the big thing about covalent bonds. Ionic bonds form between ions, covalent bonds form not between ions. The third type of bond, is a metallic bond, and we talked about that kind of at the end here. The network bonds don't really count in this. That's a combination of several covalent bonds. So the third type is a metallic bond, and they are characterized by a sea of electrons. That's the big thing with a metallic bond. Remember that key word, delocalized. The electrons in a metallic bond are not held on to one atom. They're delocalized so they can fly around all over the place. So that's your answer to number 2, the ionic, covalent, and metallic bonds, and there's some of the big characteristics of each of them. Let's move on now to number 4, and this is the biggest piece of this homework. And we're asked to complete the following table. We've got hydrogen and nitrogen and then a whole list of these other atoms with this table. And to do this, we're going to have to use the percent ionic character formula that we looked at earlier in class. And we're also going to have to use the table on the back of your homework. So if we look at hydrogen, which has an electronegativity of 2.1, and nitrogen, which has an electronegativity of, let me find it here, 3.0. We're supposed to take that and find the electronegativity difference, and then the percent ionic character, the bond type, and the more electronegative atom. The first piece here, the more electronegative atom, is easy. That's going to be nitrogen. It's more electronegative. So that far right column you can fill in already. The electronegativity difference, all we have to do is take high electronegativity minus low electronegativity. So that's going to be 0.9 is the difference. So that should fill in your first column. And then for the percent ionic character, we take that and we divide it by the high electronegativity. Or sorry, that's not supposed to be a 3. 3.0. So if we take 0.9 divided by 3, we should get 0.3. So our percent ionic character, if we then multiply that by 100, is 30%. So we've now filled in our first 2 columns and our last column. The last thing we need to do here is our bond type. And our bond type here, it's between 5 and 50%. So this is going to be a polar covalent bond. And just as a reminder, that means that the electrons are shared, but this polar means that they're shared unequally. That's the big polar, nonpolar thing. If the electrons are shared equally, it would just be a nonpolar covalent bond. Okay, let's move on now. Let's move down to that third one, potassium and bromine. And I'll go ahead and move my screen here. We've got potassium, which has an electronegativity of 0.9. And bromine, which has an electronegativity of 2.8. So again, we'll set up our formula here. We've got 2.8 minus 0.9 divided by 2.8 times 100. 2.8 minus 0.9 is going to give us 1.9. That should fill in your first column. So now we've got 1.9 over 2.8 times 100. If we divide that by 2.8 and multiply by 100, we should get 67.9% ionic character. So your percent ionic character is here. That's your second column. That means this is an ionic bond. Anything over 50% is going to be an ionic bond, and your more electronegative element is the bromine, just simply because it has a higher electronegativity. Remember, it's more attracted to electrons, or it's more attractive to electrons. So that should fill in your 4 columns there. For the last one here, let's go ahead and do oxygen, just for a look at something different here. Switch colors, and I'll move my screen a little bit and erase some stuff. If we look at oxygen here, obviously we're only going to have one type of element, and oxygen has an electronegativity of 3.5. So there's not going to be a more electronegative atom here, obviously, because we have oxygen and oxygen. So oxygen, oops, that's not a 5. 3.5. Okay, the electronegativity difference is 0. Okay, so the percent ionic character then is also going to be 0. We would have 3.5 minus 3.5 divided by 3.5. So we would get 0 divided by 3.5 and just get 0. So your electronegativity difference, 0. Percent ionic character, 0. Bond type, this is where it's going to be helpful to us. This percent ionic character is going to be less than 5. So this is a non-polar covalent bond. So this was a non-polar covalent bond. The more electronegative atom, again, we don't really have one. That's your homework help video for Unit 4, homework number 1. I hope it helped.